What's up, guys? Let's do some chapter 19 and 21. So I kind of combine these two because it works on the calculator much the same. The process for everything is much the same with everything. So it's kind of a long lecture. So I'm going to break it up into two parts. Like, well, hey, why didn't you break it up into chapter 19, chapter 21? Just go with it, man. It's a lot of the same setup. So there's no need to set up for chapter 19 the same way we set up for chapter 21. So we're going to do it all at the same time. It's just a matter of picking exactly which test you use. So in hypothesis testing, we use a sample to test the true value of the entire population. We want to choose between two competing hypotheses about the value of the population parameter. We usually will choose between two means or two proportions. It's very similar to what we've been doing with confidence intervals, where we choose a % confidence interval, then determine what value seems reasonable. So I've got some examples listed here. The examples are simply things that are questions that we could answer or have the potential to answer with hypothesis testing. So first example says a health agency claims that the mean time it takes smokers to quit smoking permanently is 6 years. Your significant other has been trying to quit smoking for the past 8 years and has still been unsuccessful, leading you to believe that the mean time to quit smoking permanently is more than 6 years. You could test that with hypothesis testing. 2 says a local grocery store claims that they wind up throwing out 33% of the produce they bring in due to it going bad before it can be sold. You believe that they have to be exaggerating and the percent can't be that high. So you could test that with hypothesis testing. 3 says a researcher claims that his new medication can cure pneumonia 50% faster than a leading competitor. As a nurse, you find his claim to be ridiculously high. You could test that with hypothesis testing. 4. A dietary supplement claims to help patients lose an average of 10 pounds in 10 days. You believe that average is too high. You could test that with hypothesis testing. 5. A mega potato farm claims that their applications of chemicals are not causing any detriment to local water systems. They claim that everything is within the average of legal regulations, less than 10 parts per million. You believe the claim to be an utter lie due to the fact that after their last application of chemical, all the fish in a local pond died and floated to the surface. You could answer that one and figure it out with hypothesis testing. You have to have a little more information, but here's how it works. There's an initial claim about what the mean or proportion is, and then there's either a new claim or belief that the initial claim isn't accurate. You lay out the two conflicting hypotheses. You calculate to determine which of the hypotheses is correct based upon a sample. You make a decision either to reject the null hypothesis or fail to reject the null hypothesis. So that's what we do in this class. We either reject the null hypothesis or fail to reject the null hypothesis. We do not accept anything in this class. We either reject or fail to reject, because if you accept it, it has to be true 100% of the time, and in this class there's very rarely anything that's true 100% of the time. Basic steps of a hypothesis test. You want to state your hypothesis. There are two of them: your null and your alternative. So your null hypothesis is H sub O and your alternative hypothesis is H sub A. You need to check your conditions for evidence to be good, just like we've been checking our conditions in the previous chapters. Still have to have NP and NQ greater than or equal to 10. It has to be random, independent. All those same conditions, depending on which one you're doing, mean or proportions, still have to hold. You have to present your evidence to see how strong it is. You have to make a conclusion, either reject the null hypothesis or fail to reject the null hypothesis, and then you're pretty much done. You got to write it up in a complete sentence. So the first thing we're going to do is how to state your two hypotheses, your null and your alternative. So we essentially have the stuff that we started on page number 1, same questions. We're going to state the null and the alternative hypotheses. So the first one, a health agency claims that the mean time it takes smokers to quit smoking permanently is 6 years. Your significant other has been trying to quit smoking for the past 8 years and has been unsuccessful, leading you to believe the mean time to quit smoking permanently is more than 6 years. So I'm going to go to the board real quick, and I'm going to write your null and alternative hypothesis on the board so that you could see exactly how you should write these. Your null hypothesis. I'll even write it here just for a few of you first timers. This is your null hypothesis. This is your alternative. Your null hypothesis is that mu equals 6 years. Your alternative hypothesis is that mu is greater than 6 years. And it really is that simple to start out your hypothesis testing. Alright, so we did number 1, let's do number 2. The local grocery store claims they wind up throwing out 33% of the produce they bring in due to it going bad before it can be sold. You believe that they have to be exaggerating and the percent can't be that high. So, let's write the null and alternative hypothesis for this one. The null hypothesis for this one, P equals, because we're not talking about means here, we're talking about percent. You can say 33%, or I'm okay with it if you do 0.33. If you have to put this in on the my stat lab, it'll either ask you, it'll indicate whether it wants percent or decimal. Okay, so your alternative here, you think it's too high, so P needs to be less than 33% or 0.33. So null hypothesis is P is equal to 33%. Alternative hypothesis is P is less than 33%. The big thing here is don't use a mu because we're not talking about a mean, we're talking about a percent. 3, a researcher claims that his new medication can cure pneumonia 50% faster than the leading competitor. As a nurse, you find his claim to be ridiculously high. So let's write this one on the board. Alright, so he claims it can cure 50% faster, so his P is equal to 50% or 0.5. Let's write a percent on this. You believe it's way too high, so you think that it's less than 50%. So no, P is equal to 50%. Alternative, P is less than 50%. 4 says a dietary supplement claims to help patients lose an average of 10 pounds in 10 days. You believe that the average is too high. Let's write the null and alternative hypothesis for this one. So it said average, so I'm going to use mu is equal to 10 pounds. But we believe that that's too high. So we believe that mu has to be less than 10 pounds in 10 days. That's it. You should be like, well, this is really simple. I really got a handle on this. Not hard at all. Alright, number 5. A mega potato farm claims that their application of chemicals are not causing any detriment to local water systems. They claim that everything is within the average of legal regulations, less than 10 parts per million. You believe that the claim to be an utter lie due to the fact that after their last application of the chemical, all the fish in the local pond died and floated to the surface. So, what we need to do here is put this one on the board. I believe that their average, mu, is less than 10 parts per million. However, because they keep killing fish in local water systems, we believe that their average is probably greater than 10 parts per million. Alright, let's look at a few definitions. We've got the alpha level, and this is the symbol we use to represent the alpha level. It's the probability of rejecting the null hypothesis when the null hypothesis is true. Alpha is typically set as 0.05 or 0.01, which is either 5% or 1%. We want it small because we want the chance of incorrectly rejecting the null hypothesis to be really small. Okay, so your alpha level is actually your chance of incorrectly rejecting the null hypothesis. And you want that chance to be really, really small. You don't want to make a bad decision. Now we also have a p-value. P-value is the probability of our sample statistic occurring assuming the null hypothesis is true. Okay, which gives us our rules. So if our p-value is less than or equal to our alpha value, then we reject the null hypothesis. If p is greater than alpha, then we fail to reject the null hypothesis. We never accept anything in this class. We either fail to reject the null hypothesis or we reject the null hypothesis. If you write accept the null hypothesis or we accept the alternative hypothesis, you will receive no credit. I typically have a handout here. So here's what I'm going to show you. So when we're doing hypothesis test, we're going to go to stat, calc, And what we're going to do is we're going to go over here to test. So you got a z-test, a t-test, and you got a one proportion z-test. Those are the ones we're going to use. So I'll do it again. We're going to go stat. I'm going to scroll over to test. We're going to use z-test, t-test, and one proportion z-test. Okay, those are the ones we're going to use. Now if we go through each of those, what we'll see here on z-test, if we're inputting stats, because we can input data or stats, but let's just look at the stat ones. In stats, it asks for your null mean, it asks for your population standard deviation, it asks for your sample mean, and it asks for your n here. Okay, so what you'll notice here is you need your population standard deviation. So very, very similar to what we were doing with confidence intervals, we need to do here with the z-test versus t-test. So here we have our population standard deviation. If I'm looking at my t-test, what I have is my sample standard deviation. Okay, so it works off the same rules as your confidence intervals did for z versus t interval. So kind of follow those the same, and I'll try to put up a little list here on the board. Now your third option, so essentially if you have a mean, you're going to use either t-test or z-test. If you have your population standard deviation and your n is greater than 30, then you're going to use z-test. If you have your sample standard deviation, you're going to use t-test. Okay, so like I said, I'm going to show you the other option we have. So if you're given a proportion that you really only have one option for, you're going to use one proportion z-test. Okay, when you do one proportion z-test, you put your initial proportion in here, your x and n, just like we did with the confidence intervals for proportions, and then I'll show you all the rest of it when we go through the examples. So let me put something on the board that might make this a little simpler for you. Here's what we got. If you have a mean, you have two options. You got z-test or t-test. If you have a proportion, you really only have one option. So it's pretty simple. If you got a proportion, you're going to use one prop z-test. Let's go through these individually. So if you have a mean, your n is greater than or equal to 30, and you know your population standard deviation, which is, remember, population standard deviation here is sigma. You know it. Then you're going to wind up using the z-test. For t-test, n has to be less than 30. It doesn't have to be less than 30, but n is typically less than 30, and you don't know your population standard deviation. So what you'll do is you'll use your sample standard deviation. Now you will every now and then have one where n is greater than or equal to 30, but you don't know your population standard deviation, and you'll use t-test for it as well, right? But typically, with t-test, we look more or less for n to be less than or equal to, or less than 30, strictly less than 30. But, like I said, every now and then you'll have one where n will be, say, 45, but you won't know your population standard deviation, and you'll still use t-test. Okay? If it's a proportion, we're going to wind up using one prop z-test. Okay? So if the problem gives you a percent, it gives you a proportion, use one prop z-test. If it gives you a mean, use either z-test or t-test. And the first thing that I usually look for when I try to figure out whether I use z or t, do I know my population standard deviation? Because that'll pretty much answer your question right from the back. So if I know my population standard deviation, typically I use z. If I don't know my population standard deviation, I'm going to use t. Alright, so I'm not going to go through all these examples in this first lecture. I'm going to make you come back around and watch another lecture where I do all the examples, but I'm at least going to do the first one to kind of give you an introduction to it. This can be a really long lecture, and I don't want you to have to sit here for 2 hours watching me go through it. So we're going to break it down a little bit slower. I'm going to do one example here so you get a feel of it, and then you'll have to tune in for lecture 2 next class period to finish it out. So the first example says the population mean IQ is 100 with a standard deviation of 15. A statistics instructor believes that his students are below average intelligence. A random sample of 30 of his students' IQ scores have a mean score of 94. Is there significant evidence to support the instructor's claim? Let alpha equal 0.05. So step 1 says find your null and alternative hypothesis. Step 2, we need to check any of the conditions. And step 3 says test your data, which do I use? And you have to make a selection between one prop z-test, z-test, and t-test. Next, you have to state your p-value. And step 4, you have to make your conclusion, either reject the null hypothesis or fail to reject the null hypothesis. You have to state what your alpha is and your p-value. And E says write in a form of sentence the data suggests or the data does not suggest. So I'm going to put it all up on the board at one time as best I can. And try to do my best I can drawing it out. I might come back and try to enter it in on the computer as well so you can see what goes where if you're having a little bit of trouble. So try your best to follow along. Alright, so step 1, I need to state my null and alternative hypothesis. This is a mean one. It says the population mean IQ is 100. So the population mean is 100. So my null hypothesis is that mu naught equals 100. My alternative hypothesis would be that mu is less than 100, at least for this individual group of students. Okay? We need to check our conditions here. So in the check conditions, if it's a proportion, you're going to want to check that NP and NQ are greater than or equal to 10. You're only doing so much. But this one, you need to check your randomization condition. Make sure these students are chosen randomly. That's up to the professor, how he chooses them. You need to make sure that they're independent. I'm assuming that each student's intelligence is independent of each other. That seems to be fine. So random and independent. They seem to check off. The other thing that I'm going to do under check conditions is I'm just going to state a few of my facts here. So here my N is equal to 30, right? Because there's 30 students. My mean here obviously is 100. We've kind of already stated that. My standard deviation, I know my population standard deviation here is 15. So I have a lot of the information I need to kind of move forward with the problem. Step 3 wants me to choose between one prop z-test, z-test, and t-test. Okay. Here, N is greater than or equal to 30, because it's equal to 30, and I know my population standard deviation. So I need to use z-test. Okay. Next thing it asks for is p-value, which means I actually need to sit down, use the calculator, and go through doing it on the calculator to find my p-value. And I'm going to show you exactly how to do that. So let's go to the calculator real quick. So we have chosen to go with z-test. So let's get to z-test. We'll hit stat, go right. Z-test is the very first option. Now it asks for your mu naught. In this case it was 100. Hit enter. It asks for your population standard deviation. Here that was 15. Ask for your X bar in your sample. Okay, so if I pull up the question, it says a random sample of 30 of the students' IQ scores have a mean score of 94. So that's what I'm going to use here for that. So my X bar here is 94. N, we decided that was 30. Okay, now we have to make our decision here. Okay, and this is the really important part. If you don't make your decision right, then it's going to mess up everything in your entire problem. Here we said that we believe that we are less than our mu naught. So essentially we think that our students are below average intelligence. So we think they're less than. So the one we need to highlight is less than. Okay, this the way I actually teach it is this signal should match the signal that you had up there on the board, and I think you can actually still see the board behind the actual thing. You might not can see that very top part though. That step 1 part up top. Whatever your H sub A is, if it has a less than in it, that's what you need to highlight right there. If it has a greater than in it, that's what you need to highlight right there. And that's typically the way I teach it. Okay, so make sure you highlight the right one. Now, you can do it in whatever color you want to. You could calculate or draw it. I prefer to calculate it. Okay, so when you calculate it, it gives you all your information. It gives you your z value, your p value, your x bar value, and your n value. The value that we're interested in is this p value right here. Okay, so p equals 0.01422988183. Okay, that's the value that we're interested in. So let's go put that p value up on the board and work about finishing this problem. So I put my p-value on the board. P-value is 0.014. I just rounded 3 decimal places. Now, step 4. We need to reject the null hypothesis or fail to reject the null hypothesis. And what it really does here is it takes, and you can basically use B and C in this part to solve your problem. So we already know what our p-value is. We've done that. Let me double check the alpha value we decided to use here. The alpha value we decided to use here is 0.05. So alpha is 0.05, your p-value is 0.014. So if we're looking at it here, which one's smaller? So here, p is less than alpha. Okay, that's when we need to go back to our rules. Okay, so p-value here is less than alpha. Therefore, I am going to reject the null hypothesis. Okay, so a lot of the students really struggle with this piece right here. Okay, so you got to compare them. Okay, if p is less than alpha, we're going to reject the null hypothesis. If p is greater than alpha, we're going to fail to reject the null hypothesis. You got to keep that rule down. Do what you got to do. Get it tattooed on your arm. Whatever you got to do, get that part down, because if you mess up that part, it'll essentially mess up your whole problem. It'll mess up your conclusion. It'll mess up everything. So you really got to know your rules, or specifically this rule. If p is less than alpha, I reject the null hypothesis. If p is greater than alpha, I fail to reject the null hypothesis. Now we need to put it in a formal sentence. And if you notice on your notes, it says write it in a formal sentence. The data suggests, or the data does not suggest. That's not the only way to write it, but that's a really good way to start writing it. So here, what does the data suggest? So if p is less than alpha, I reject my null hypothesis. So the data suggests with an alpha equals 0.05 significance level, and a p-value of 0.014, that I reject the null hypothesis. Okay, but you also need to relate it to your actual question. So if I reject the null hypothesis here, that means that I don't think this is right for this particular set of students. I think that this particular set of students really is below average intelligence. So here, the data suggests this selection of students is below average intelligence. And that's essentially how you do hypothesis testing. Now, you'll be doing most of your stuff on my stat lab to finish out the semester, so you're not going to have to write really big long sentences, but I do need to show you how to do it. So I'll do it with all the examples coming up in part 2 of this lecture video, which you'll see by next class. But this is essentially how you go through it. Okay, I know I've only done one, but the t-test essentially goes the same way. The one proportion z-test is a little different, but it essentially goes the same way, with the combined way we find x, the x value for it using the proportions, same way we did it in the confidence interval for the proportions. Other than that, you should be able to at least maybe get a grasp on some of this. Take your time, go through it, read through it, make sure you get your definition straight in your head, and we will do a whole lot more examples in the very next video.